Alright, chapter 7.2 is getting into multiplying powers with the same base. Today again we're going to look at another power property. I think we talked about two in our last lesson. So we got one more here. This property is the multiplication property. It's pretty simple to understand on its own, but again, as I said in the last lesson, when everything gets put together it's kind of confusing. And so what I want to do with all these properties is give you a breakdown that allows you to use common sense if you ever have to. So let's expand these things here and simplify them. You have x to the fourth times x to the sixth, and there actually is a question like this in your Math Excel to where all you have to do is take the x to the fourth, and remember that this represents 4 x's, and multiply by this, which is 6 x's. And if you simplify that back into one group, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 x's, which is your final answer. And again, on the Math XL, you will have to type these x's in and you will have to simplify it back down. But again, it's just my way of making sure I know you understand. This represents 4 x's and 6 more x's, which make 10 x's altogether. Same thing over here. Y to the third is y times y times y. You have a y right here. I'm sorry, it's just y, y, y. I'll do that again for you, I'm sorry. So it's 3 y's here times a regular y times 5 y's. And again, when you push all those back together, you get 1, 2, 3, 4, 5, 6, 7, 8, 9 y's as your answer. The trick on this is that a lot of people, whenever they do the multiplication property, they forget that there's a y here. They forget that there's a number there, so it does help if you at least understand the expansion part, because again, using your common sense will help. So whenever you're stuck, be sure to think of just expanding the exponents. Again, you don't really have to expand them, but if you just kind of mentally say, well, there's 4 x's here and 6 x's here, so that does make sense to be 10, because a common error that we see, or that I see on a test and all the math teachers tend to see in their tests, is that people take x to the fourth times x to the sixth and they get x to the 24th. But again, if you have 4 x's here and 6 x's here, our common sense says that it can't be 24 x's, because that's a whole lot of x's for just 4 and 6. But you know, I mean, that's something just where you want to be careful to understand the rule. That way, whenever you get an answer that, you know, that if you go off of the wrong instinct, you can still kind of check yourself before you put the wrong part in there. So the rule for this is as follows. When multiplying powers with the same base, you simply add the exponents. That's it. Again, this process is best learned through practice. So let's look at the different types that you're going to see in your homework and then move on. If you're asked to do e to the 28 times e to the 19th, I don't think you want to put 28 e's and 19 e's, which is where you want to understand. You will simply do e to the 28 plus 19 up here. Then you'll add 28 and 19 to get the answer of 47. Again, on your Math Excel, you'll have to type this step in first and then this step in second, just to make sure you understand that in this problem here, you're adding 28 e's and 19 e's to make 47 e's. On the other one, again, this is a p to the 29th, p to the negative 41st. So the first thing we do is we take 29 plus negative 41, which gives us the answer of p to the negative 12th. But if you remember from the last section, you can't leave a negative exponent, so this negative 12 actually wants to equal 1 over p to the 12th. So again, this turns into the addition of the problems here. That turns into a negative exponent, and that leads us to our final answer of 1 over p to the 12th. Again, on your homework, you have to show all 3 of those steps, but that is just my way of making sure you understand each of those things as it goes. So again, if you get stuck, let me know, because it's easy enough to fix once you get into it. On C, this one here is where we kind of put some stuff that we talked about in the last section together with this. If you remember, we broke them down into parts. You have a g over here and a g over there. So what we are going to do is put g to the 13 plus, there's no number there. And again, the key thing is people tend to make the mistake to assume that this negative 24 goes with the g. It only belongs to the s, but there is one g there. So it's 13 here, 1 there, and then s to the 25 plus negative 24, which ends up as g to the 14th, s to the first. Now here's the problem. You don't write a one exponent, or you don't write an exponent of 1, so what you would actually write is just g to the 14th s. I believe I tried my best to make sure on the computer program that if you type in s to the first that it marks you wrong, just so you get that out of your habit of putting a 1 as a power. Okay? But again, put your parts together. G goes with G, 13 plus 1. S goes with S, 25 plus negative 24. Simplify each part and rewrite each part, kind of like you did again in section 7.1. So it's slowly building, but again, just make sure you're keeping up with everything, because if you don't, it's going to get ugly really fast. Here again, you have a K here and a K here. You're still multiplying these two, and so you end up with K to the 3/5 plus 1/2. Now I understand that we do have calculators that do fractions, but some of you just took the PSAT or the SAT pre-test or whatever it might be, and I think you understand that there are tests that they give you with no calculators in which you have to be able to deal with fractions and decimals. So let's just look at that real fast off to the side, because that's pretty much how you kind of want to do it. 3/5 and 1/2, remember that in order to add a fraction, you have to have a common denominator, so you ask yourself where 5 and 2 meet, and they both meet at 10. 5 multiplies by 2, so multiply the 3 by 2 to get 6. 2 multiplies by 5, so multiply 1 by 5. And so you end up with 11/10, and that will end up as K to the 11/10 is your final answer. So again, when you see the fraction question, I know you probably have calculators that can do the fractions for you, but you're not going to help yourself out in terms of future assessments or pre-tests that they give you in college and things like that, because they expect you to be able to do the skill, not just to be able to find the answer. So make sure you at least try a couple, and if you have any issues with it, bring it over to me so I can talk to you, or whoever your teacher is, take it to them so they can talk to you. I'm sure they will help you out as long as you go and let them know before it's too late. E. Use a calculator to evaluate the expression for the given values. Round to the nearest 10,000. So this here is a pure calculator problem, and I want to make sure we understand what you need to do. Remember, what you've been trained to do is that anytime you're going to use your calculator, actually anytime you substitute in general, that you use parentheses, because what people do in the wrong way is they do something like negative 16 to the 8th, and they type it in this way. Remember that if you want to do the 8th power, use that caret button, which is the one that points up, and they get this answer, where if they type in negative 16 to the 8th, you get that answer, and that is where the mistake is. So you have to be careful, making sure you understand, again, if you're going to substitute, you must use parentheses, because your calculator will give you the right answer, but if you type in the wrong problem, then of course you're going to mess up. So every letter we shift, or every letter we substitute, we want to use parentheses, so we put parentheses, negative 16 close, because that's the only part of x, 8, and then we put parentheses, negative 3 to negative third, and you simply type that answer in. Making sure I got that right. Yep, that is y. And then you hit enter. Oh, it didn't make me do it. And so that would be the answer you actually have to type in for me, which is negative 159072862.8. The thing is, it says round to the 10,000th, and there will be some questions on your homework that won't be this. I guess I'll call that nice. How do you know where the nearest 10,000th is? Let's say that I got an answer. This is your answer for your notes. But let's say I got an answer in my calculator that said 1.2345678911011. If my calculator went that far, how do I know where the 10,000th is? Because a lot of us haven't reviewed that skill. The way you find out where it's at is you write the number 10,000, and you count the zeros. 1, 2, 3, 4. And however many zeros there are in that number, that's how many digits you want. So we want 1, 2, 3, 4, which means we would cut off here, and this would be 1.2346, because remember the 6 would bump that number up. So when you do your work on the homework, if your answer doesn't end up this nice, where it just goes to 1 decimal point, and it goes way beyond the decimal, just remember that the 10,000th is 4 zeros. Just like the 1,000th is 3 zeros, the 100th is 2 zeros, and the 10ths is 1 zero. So again, use that whenever you see those kinds of questions, so you understand that also. Two more things you're going to do, actually one more thing you're going to do is scientific notation. This doesn't require any extra work, but you just need to understand it if it happens. And you're going to again use the parts here. You have a whole number and a whole number here, so you're actually going to do 3 times 4 in one of your problems. And the other part, you're going to take the numbers that have exponents and do 10 to the 5th times 10 to the 3rd. And so 3 times 4 turns into 12. Sorry. And then times 10 to the, it would be 5 plus 3, which would be your 8, because remember we add those two together. And then notice it says write in scientific notation. I picked this because scientific notation is a very sensitive notation to use. And if you, even though you have the times 10 to the 8th, you need to understand that this is not scientific notation, because your number needs to either start with anything from a 1, a 2, a 3, a 4, 5, 6, 7, 8, or 9. It can't start with a double digit, and this number here is a 12, which means we have to actually adjust it. And what we're going to do is turn this into 1.2. So again, in order to make this true scientific notation, we must turn this 12 into 1.2. We still keep the times 10, but this is where the balance of numbers comes in. You simply ask yourself whether you made this number bigger or smaller. To go from 12 to 1.2, that got smaller. And so in order to offset that, you have to now make this number larger or bigger, which means that if you moved it by 1 decimal point, because we did, then this moves by 1 decimal point to be bigger, to make 10 to the 9th. Again, please make sure you ask me about this when you get to it. Don't just guess. This needs to be understood. You never know whenever you'll bump into a question that this pops up on. But again, this is a good time to talk about it since we're talking about power properties. But again, that is how the balance works. You do the initial work. 3 times 4 is 12. 10 to the 5th, 10 to the 3rd makes 10 to the 8th. But since that is not the general form, you adjust the number and then you offset that adjustment. If that number gets bigger, that must get smaller. If this gets smaller, that must get bigger. And you just kind of offset it, kind of like you would a seesaw. One side goes down, the other side goes up, and that is where the balance is. Here again, same thing. 0.1 times 6 is 0.6. 4 and should be a negative 11 there. Sorry. Make sure you put that on your notes. That is a negative 11. 4 plus negative 11 equals negative 7. The problem again is I told you how to start with any digit 1 through 9. This starts with a 0. So what we have to do is turn 0.6 into a 6. And again, keep in mind this just got bigger, which means this must get smaller. Now be careful, because when you make a negative smaller, we usually think that 7 is smaller by turning into a 6, but negative 7 gets smaller by turning it actually into a negative 8. So again, playing that game, just be careful. Those are the things you have to look out for whenever it comes to scientific notation. So again, if you get stuck on that or you don't understand that, be sure to bring it over whenever you're working on it so I can actually talk to you about it and try to help you out. Just remember, all these processes need to be instinctual. Also be sure to learn the foundation work to the process so you can think your way through the problem if your memory doesn't work when you need it to, because again, math is basically common sense. So just make sure that you have the common sense side as well as the instinct side, so you can kind of double check to make sure the answer is what it needs to be. Other than that, let's go ahead and get to the work. Good luck.